Good morning, students. Welcome to the class on photochemistry. In this class, we will deal about the physical part of photochemistry, how these reactions will occur, the calculations required. What is photochemistry? Photochemistry is nothing but the reactions which occur under the influence of light. So when we pass a suitable light onto a chemical compound, then it will undergo a chemical reaction to give the product. So this is basically what photochemistry is. Photochemistry deals with the study of chemical reactions which are caused by the absorption of light radiation. Generally, we use UV visible light for doing photochemical reactions. Thing is that visible light is abundantly available, and to some extent UV light, near UV, is also available. So whatever we do in photochemistry, generally we use UV visible light, so that we can perform this reaction under normal sunlight also. In principle, a photocatalytic reaction must also occur under sunlight. Why? Because we are using visible light and near UV light for a photochemical reaction. Generally, sunlight also contains this range of light. So, in principle, a photochemical reaction must also occur under the influence of sunlight. So that is why generally we use this light. And another reason is that when we use UV visible light, this light when we use UV visible light, when the molecule absorbs UV visible light, it excites an outermost electron from the ground state to the excited state. This is what is called energy absorption. Energy absorption. So because of this energy absorption, a chemical reaction will occur under the influence of UV visible light. So energy absorption is the most important process for a photochemical reaction. Of course, we know many reactions which occur under the influence of sunlight. Conversion of carbon dioxide and water into useful products like carbohydrates and oxygen. This is the best example for photochemical reaction. It occurs in the presence of sunlight and a green pigment, chlorophyll. This is the best example for photochemical reaction. So this is how nature develops food. We can balance it. There are two basic laws in the photochemistry. What is a photochemical reaction? Take the compound in a vessel, then pass light onto the solution of the compound. For example, I naught is the intensity of the light absorbed. I naught is the intensity of the incident light. Then some part of it will be absorbed, that is what is called IA, and the remaining part will be transmitted. So that is intensity of transmitted light. So when we pass light onto the material, only some part of it will be absorbed. Okay, not all complete light will not be absorbed. So based on this principle, there were two basic laws. First one, Groth's dropper law. What is Groth's dropper law? According to Groth's dropper law, not all radiations can cause a chemical change. So when we pass light onto the material, the complete entire spectrum of light, what we are passing, it will not result in a chemical reaction. Only those radiations which are absorbed by the molecule only those radiations which are absorbed by the reacting system are effective in producing a chemical change. So according to Groth's dropper law, only those radiations which are absorbed by the molecule, they will result in chemical transformations. Okay, so when we pass light onto the material, only those radiations which are absorbed by the molecule, they are only responsible for the chemical transformations. It is just a principle. Okay, it is just a basic law. Second law, law of photochemistry. This is most important. Law of photochemistry was proposed by Stark and Einstein. So generally it is also called as Einstein's photochemical equivalence. So this law is also called as Einstein's law of photochemical equivalence. What is Einstein's law of photochemical equivalence? This was actually proposed by Stark and Einstein. This law states that each light absorbing molecule each light absorbing molecule in a photochemical reaction absorbs only one quantum of radiation, which causes the activation. So, according to Einstein's law of photochemical equivalence, every light absorbing molecule absorbs only one quantum of radiation. Einstein's law of photochemical equivalence is applicable to only primary process. We will discuss mechanism of photochemical reactions in the next class. So there we will come across primary process and secondary process. Then I'll explain it. So Einstein's law of photochemical equivalence will only applicable to primary processes in the photochemical reactions. Of course, by Planck's law, we have energy expression. What is Planck's law? E is equal to h nu. E is equal to h nu. So change in energy. Say for example, this is ground state and this is excited state. Then the energy difference between these two states, which is called delta E. Delta E is equal to h nu. The energy possessed by h nu, it is called one photon, right? One photon. Here nu is nothing but frequency of light. Frequency of the light. So energy possessed in one h nu, it is called photon. That means one molecule absorbs one photon of energy in a photochemical reaction. So each molecule absorbs one photon of energy. Now, if we want to calculate the energy for 1 mole of the compound. What is 1 mole? What is 1 mole? In 1 mole, we will have Avogadro number of molecules. In 1 mole of a compound, we will have Avogadro number of molecules. So energy absorbed per molecule is h nu, and if we want to calculate the energy absorbed by Avogadro number of molecules, we need to multiply it with the Avogadro number. So when we multiply photon with Avogadro number, we will get energy absorbed by 1 mole of the substance. It is called Einstein. So 1 mole absorbs 1 Einstein of energy, whereas 1 molecule absorbs 1 photon of energy, 1 mole absorbs 1 Einstein of energy.